All right, so just a reminder that we're working on Project 1 to October 8th. You should definitely be getting like a kind of a good feel for what you. Oh, hold on a second. I realized I got my audio off. All right, let me know. Um, so I didn't know if anyone was speaking earlier, but I just turned my speakers on my computer. So in case somebody says something, I can hear you now. All right. Right. So you're getting a little deeper in your project. September 22nd. We've been going for 2.5 weeks, maybe. So we've got another 1, 2. We gotta have it due on a Friday. So you got another 2 weeks. You should be like halfway through your goals, your project, your stated goals. If you don't feel like you're halfway through, or you feel like you're still ramping up with practice or tutorials, what have you, maybe you should think about making sure that your backup goal is still good for you. For today, I'm going to go through some of the codes, the scripts that are running things, but I still wanted to kind of wrap up talking about meshes and mesh renderers, because I know we spent a lot of time on. Let me see if I can close this window. Yep, I know we spent a lot of time on the particle systems. You can't hear me? All right. Can anyone not hear me? So it's like one person cannot hear me. Alexander. Okay. Let me just see if there's anyone's waiting in the lobby room. No, I think we're good. All right, let me minimize this. It works. Perfect. So yeah, I just wanted to go over. I'm still working on the first person shooter project. We kind of went deep into it just to solve an area for one of the students. So we're kind of focused on the particle systems of the guns and the projectiles that they're making. Remember that all the guns are prefabs, all the projectiles are prefabs, all the explosion at the end of the shot is a prefab. Prefabs get instantiated via code, get destroyed via code. They're like game objects that are sitting on your hard drive, all pieced together with all their working parts. And the benefit of that is you don't need like all these like tons of these game objects that are in your hierarchy that you're not going to use at runtime. So you only place in your hierarchy what you need at runtime, and you instantiate the rest. It's worth making a quick note on that. That if you're instantiating a lot of stuff, gun bullets would be one thing. And you're experiencing a slowdown. So just knowing game stats here, there's frames per second. If you're getting a slowdown, meaning you're starting to drop down into that 30 frame per second or less, and there's this kind of visual lag. Um, Note that yes, you can instantiate objects, but you should be tracking them and you should be destroying them when you don't need them. So bullet projectiles are a perfect thing to talk about. As your gun, especially like an automatic type gun, is firing many bullets a second. Those projectiles, those like that show like the streak of the bullet flying and keep track of where the bullet is. Eventually, that bullet either hits a wall and or a floor, and it like creates an explosion prefab, or it keeps going and it just like leaves the game level. If you click in the scene here, it just keeps flying out here. Eventually, you need to keep track of these things and destroy them. So there's nothing worse than having thousands and thousands of prefabs being built up and not being destroyed, and majority of them just are not being used. So the next best situation is a smart instantiate only what you need when you need it, and then destroy stuff when you don't need it. So that's a good method. But even that can start to um, bog the system down. So um, managing your own prefabs by instantiating and destroying them is great, but it's actually an expensive operation to actually instantiate and then to destroy as well. So I haven't dug into code deep enough, but I don't know if they're doing something like this. But it's common to have what are called pools. So you might have an enemy pool and a bullet pool, um, and you might recycle them. So in this case, I'll just say like bullet pool. So depending on which gun that the that the player has swapped to, you might fill out. So let's just say, oh, the user has swapped to the disc gun, right? I might fill up the bullet pool with like 10 disc bullets, or however many makes sense based on how quickly the gun is firing. And then you just instantiate 10 of them and you turn them off, and then you use them as needed. So you keep track of what's turned on, what's turned off. So, for example, if he's shooting, this bullet is flying. I just turned it on. It's moving through the game world. And then he fires. If the player fires again, I might turn on the next one that's available, and he fires. But these are still being tracked through the game world. They're still existing. There's no point in removing them. Let's say that the player creates another one. He shoots. And let's say by the time he's shooting here, let's say at some point this original bullet leaves the game world. It's traveling fast enough where it's leaving the playable area. It's useless at this point. My pool of objects, my bullet manager or whatever you're going to call it. Let me just say quickly that managers, coordinators, um, con, yeah, controllers, coordinators, managers. There's many different names for these type of things in programming, and it just means like a central location, a central script that is managing some aspect of logic. In this case, it's managing this pool of bullets as they're firing. But let's just say this manager has determined that this original bullet has moved too far outside the game world, right? And it's no longer useless. So we don't need to track it anymore. We just need to turn it off, disable it, and we don't need to move it. We don't need to like the physics system and doesn't need to keep track of it. We don't need to manually update its transformer, however it is that you're moving it or and tracking enemies that get hit by it or whatever you're doing. You don't need to do it anymore. And let's just say we fire again, and then this one, maybe it moved off in another direction. Maybe it moved off this way, and it's too far outside of our game world, and we can disable it. So you see how we start like moving down our pool. So right now these are the active ones, this one, and so on. This works for anything. You might notice as you're like running through a game world that like trees, like their distance threshold isn't like set the best, and they might kind of pop into existence at your far um, your far vision. The tree might all of a sudden appear, but it might be kind of noticeable or jarring. And that's they're using these type of pooling systems. So they'll use it with trees and fruits and pickups and enemies and like idle props or houses or bullets. But just know that we're not. Point is that we're not always creating and destroying stuff. We have to go through like a massive creation situation, and then we can just like turn on and off and manage sections of our pool, and then we don't need to go through a destruction, which is also an expensive process. So just something to think about. Pooling is like the next strategy. um, so I'll turn that off. um, if you haven't noticed already, the UI is really big. I think I talked about it. It's off to the right. Your game world's down here in the center. This is what screen UI looks like. It's kind of annoying sometimes. You can go through the gizmos and turn stuff on and off if you don't like seeing it. Um, while I'm just on the topic of um, the interface, The standard stuff is here: file, assets, game object, components. Just that Cinema Machine is in this case it was imported and it's used as part of um, the first-person shooter micro game. But the Cinema Machine is another package. It used to be an external asset managed by a third-party system. You got to go through login. I don't know if I have my password right now. That's all right. But just know it's a package. It was bought by Unity. It's now an internal, what they call package. Cinema Machine, Cinema Brain. Um, it's like an animation system. So it's for cinema. It's developed for the idea of cinematics, where say you beat a boss, or say some major game moment happens where you don't have control of your character as much or at all, and that's what's called a cinematic. So they're explaining a story, there's some dialogue, some events are happening, and it's not active gameplay. Yeah, you might be able to move the camera a little bit, you might be able to move the character and do some very limited things, but it's not like a fully interactive experience. So Cinema Machine, so when like all these like sophisticated camera movements and all these animations of things happening, during a cinematic, it's kind of complicated to manage just by code, and that's what this Cinema Machine does. Now, it's also used in the interactive parts of the game where you might want the cameras to be tracking. Maybe if you're running through the world, your character is exploring, and during exploring mode, the camera is kind of like far away, but it's kind of behind you, and you can see a lot of the environment to make exploring decisions. But let's just say you stumble upon a party of orcs, and all of a sudden you go into combat mode. And let's just say that your logic can pick up the difference between exploring mode and combat mode. And once you're into combat mode, the camera changes. All of a sudden it's tight and close, and it moves around you really quickly so that you can understand like where the enemies are or whatever the camera logic is. That's what a lot of these can do as well. So there's a lot of what Cinema Machine can do during what they call cinematics, and also what you can do at interactive. So if any parts of the projects you're working with have like these big animation tracks, it's under Window, Animation, um, and I think Sequence, yeah, Timeline. So you might see assets that are called like timeline assets down in your project or whatever. And to view them, you have to look into these windows. All right. Tools. So Pro Builder. Oh, so profilers are interesting. There's a mini profiler. Um, and where's the main one? Let's see 1 second. Analysis profiler. So this kind of shows you. This is even more in depth. If you click play and you play your game, this profiles it. So this isn't just games. Like software does this too. It's like there's a lot of processes that are happening, a lot of pieces of code. And as you see here, this is saying, well, how much computing power is rendering in your scripts and physics and animation and garbage collection taking up. So you pause this and you'll review like different parts of your game. What's really bogging down? How can I optimize specific sections of my game so that I can use that processing power for other things. Ultimately, you want to push the threshold. You want to always be doing something that's interesting and fun and adding new systems and using up all the amount of processing power that's available on your machine while making it fast and like super quick visuals so that users have a fun visual experience, but also their input is really like responsive and they feel like everything is real time and everything is like responding to them really quickly. So anyway, that's a profiling tools. And there's massive forums and tutorials on all these different things. So Pro Builder was also used to be external and the asset store, and now it's internal. It's like Unity's prototyping tool set. You can make geometry. In fact, this whole level was created with Pro Builder. They didn't need to go into a third party what they call DCC, are like direct content, basically content creation packages like Maya and Blender and Houdini and Adobe Photoshop and all this kind of stuff. You can just make 3D models right in Unity, lightweight, simple ones. That's why the all the models are very like blocky, and the textures are like this grid stuff because they were created right within Unity with ProBuilder, and there's tons of tutorials and stuff for this as well. Publish is some special button for doing WebGL publishing that this project has. Jobs and the burst compiler is a new. You don't need to worry about it. It's how to do more data-oriented programming as opposed to object-oriented programming, more of a multi-threaded scenario where Unity is Unreal or most game engines are single-threaded. It's a performance thing. It's a different way to write code. That's outside the scope of this class. Tutorials. So that's what this thing is over here. Before I closed it, I left it open. There's a bunch of interactive tutorials built into this project, and you can do them at your leisure. So I'm going to close that. Just wanted to make it aware for those of you who are not aware, and then all the other windows, rendering and animation in general that you need. All right. So I just wanted to ground everyone because I know I kind of did like a deep dive, and then there might be all these other questions coming up. So now that we're back in the main, we're in the secondary scene. I wanted to just kind of look at what these major game scenes, what's happening in their hierarchy. So again, we have these these spacer objects, super useful, but there's no logic. They don't do anything. It's just for ease of knowing what's going on here in the game to start with. So we have general game manager has a bunch of scripts. We'll look at these briefly. An audio source. There has to be at least one camera and one audio. Um, not a source, but what's it called? Listener. Where's the listener? Maybe it's down into the camera. Here we go. Audio listener. There's one camera for the user. There can be other cameras doing other things, doing other types of rendering. But we need a camera for the player, and we need a listener that will assemble all the audio sources and then pipe through the player's speakers with the final composite audio sounds like. So in this case, there's like ambient wind sound on the game manager and a bunch of scripts. There's some stuff underneath it. We have the HUD, which is the jetpack counter, which is probably this thing. Let me turn on. Let me open it up. This is the entire HUD. Yeah. Okay. So this is okay. Here we go. Jetpack counter. It's under bottom left corner. Yeah, it is a jetpack. All right. So these are all the parts of our HUD. Right. So jetpack, weapon HUD manager, player health bar, the feedback flash. I guess when you get hit, there's like a red flash. Yeah, damage flash. And when you heal yourself, it's similar. There's a frame rate counter. Let me get rid of my stats. I didn't notice a frame rate counter. Let me play real quick. Let's see, tab options. Oh. All right, maybe they turned it off. Frame rate counter. There it is. Cool. I'll see what to open up that script later and see if it's the same as. This is like 300. So this is coming in at 150. All right, so it's the game HUD. And the in-game menu, so I guess when you press tab here, that's what this thing is. So these are the objectives. So for this level, which was called the secondary scene, the objectives here, you have to kill 6 enemies to finish it, right? So they reuse this script for different levels. And then there's this event system. This comes with Unity. This is whenever you make a UI, it has to be in here, right? So there's all the general stuff. Let me shrink it all down. And under the player, we just have the player. Here's the enemies. I don't know if these guys, I have to look a little deeper if these are getting spawned, because we have 3 enemies and the objective is to kill 6. So I have to see how that's working out. But anyway, here's the patrol pass for the enemies. Here's the pickups that are currently available. We got a launcher, shotgun, a bunch of health stuff. The level itself, just the geo for the level, which was made with Pro Builder. A light source and a mesh of the sun. Okay. So I guess maybe it moves. Does it move? Follow the player. Okay. Ignore heat map. I'll take a look at this. Probably not doing too much. But anyway, we have a sun mesh that maybe if you do want to like change the time of day, you can rotate the light and rotate the sun and the light changes. But we have 2 VFX systems as well. One for lava. You can see it kind of sprinkling here. And I could pause it just so you can see that it is. That's the particle system that's moving. Here's the parameters of it. I'm not really going to go over this again unless you're interested. And here's dust. So it's probably hard for you to see, but there's these like very light red blobs moving back and forth. If I pause it, that's one of them there. But I think maybe if you go into game view, let me click play. Let me see if these 2 particle systems are just running. Okay. So that's got to be, yeah, that's the lava. And dust, there's this little granular dust thing. It's probably not coming through on the screen capture, but it's there. Those are these little, to give it feel like the world is alive outside of you. The ambient wind noise and these very light particle systems. Oh, Unity crash. And then I just wanted to show you how this environment, this like lava world environment, is being rendered. And then I can, I wanted to go into the game manager scripts, and I wanted to talk a bit about the mesh render. Anyway, just give me like a minute. Unless you have any questions, you can post them, but it's going to take me like a minute to get Unity back up and running. Does all make sense so far? All right, we're back up. Could someone just type hi just to make sure I'm actually still broadcasting? All right, perfect. So let's see. The game world. So what is this world around us? So I think that's in the lighting window environment skybox. It's in materials. Yeah, okay. So here's the skybox material. So it's basically an image that's, if I just keep zooming out, you see like we can never escape the environment. So it's this like super infinite large sphere around us that you don't have access to, that you can wrap an image on, and so you feel like you're you feel like you're inside of it. In this case, it's this massive panoramic image of this lava world. So I can right click on it, say show and explore, and if I right click and say properties, so okay, it's a material, MAT. So I wanted the image. So this spherical HDR image, I select that. There it is. Right click, show and explore. Here we go, 4K PNG. So PNG is an image file. This is ultimately just like a massive panoramic. Notice it's very long as opposed to high. And this is wrapped around a big sphere in a panoramic manner. All right, so it's a texture that's applied to a material that's wrapped on a big sphere around you. And that's the skybox. And then this contributes to when you have a skybox under window, rendering, and lighting, and under environment, this actually contributes to like the color, the lighting color that gets applied to your models. So we have the real-time shadow color, this dark blue, an ambient color, this type of like sky light blue. And then we have this big directional light source here, which is giving a reddish color onto everything. And it says missing lighting setting. So I don't know if this skybox material is actually casting all this range of colors onto the object. So I'm going to say no, just because that's expensive and it just doesn't. This everything's kind of low quality. I can see the red light and the blue of the shadow here. So let me see where it's. Somehow it's coming through. Oh, real-time shadows, real-time object shadows. Okay. So notices the ambient color. It's like a lightish blue. That's great. Notice that there's a color coming from the directional light. It's just this thing. So I can completely change whatever. In this case, we're going to have green, and our ambient color will be like a, for whatever reason, like a purple. I don't know. Whatever your environment is. Now, real-time shadow color is going to be it's real-time generated. Those are the actual characters that are moving about. So you don't see it because there's no characters in here. But if I get out of this, go to scene and zoom in on my player, probably these rotating weapons and stuff might be giving it. So this shadow here, I think, should be real-time shadow color. They might not. There might not be any components giving. It's very hard to zoom in and out and stuff when there are some objects underneath their hierarchy or a wide range. Now this isn't giving a shadow. So I think this real-time shadow color is not impacting anything. Nah, their hoverbots don't seem to be. Oh well. So that's how you diagnose what's actually connected and running, what's not. That part's not connected with the lighting system. I'll quickly just grab this model. Like this launcher here. So these little ninja stars, that means shuriken. That's the old name for their particle system. So whenever you see that, you mean there's a particle system within this grouping. You can just turn off gizmos for now if that's in your way. I can click on this model, this pickup launcher. At the root of it, there's just a box collider and a rigid body, and it's a script. And so this collider and rigid body makes it part of the physics system so that you can walk up to it, and there's probably a script on the player that knows when it picks up stuff. This mesh is an empty, just a group object. So underneath here, we have this weapon controller script. weapon fuel cell handler charged. So normally with the pickup object is not the actual prefab for whatever the functioning object is. So it's just like a shell. It's just like once you pick up the object, the gun. In this case, what I'm trying to say is that I think this weapon has pickup, has all of it, is the same actual prefab when you're holding it, which is, I guess they did it for simplicity, but normally you don't do that. You have like an empty prefab or a non-functioning prefab that sits out there, and then a real like functioning prefab when you use it. What I wanted to look at was some of the mesh parts of this thing. All right, the muzzle. No, that's just that's just the location. Okay, so this gun muzzle is a transform that's used whenever you fire something. It needs to know where to start moving the projectiles. So that's, I bet you, yeah, gun muzzle, weapon muzzle. So this script uses that location to know where to spawn the projectiles and stuff. Anyway, here we go. Mesh weapon. Um, so I know there's a lot of different parts of it, but notice that when you click on actual mesh now, it's got this orange about it. So I'll move one part out. So it's a prefab, or part of a prefab. It has a name, has a transform, its position, rotation, scaling within this hierarchy. So there's this idea of local, global transform matrix and then local transform matrix. This is local numbers. Um, but if you click on here, global, um, notice the orientation of the gizmo changes. So that it's already kind of angled and rotated, and the gizmo's rotated with it. And the center point you don't need to worry about. All right. Just know these numbers are local to its parent here. But in your code, you can grab and manipulate either global or local numbers, and whatever's easiest for your calculation. In any case, the next component is a what they call a mesh filter, and this brings in the actual mesh. In this case, the external file that represents the geometry, not the shader, not the lighting, not the camera, but the actual points that get edges drawn between them, and those edges form the polygons, the polygonals, the triangles, the quads, what have you. So I'm clicking on the file here in the project view. That's the name. FBX is a very common 3D file. So for just this part of the gun, you have this many vertices. The vertex is just a point in 3D space. The vertex, notice that there's these kind of arrays of floats. So the position needs 3 floats. A float is a decimal number to describe its position, X, Y, and Z. All right, that's why position has 3 floats. The vertex, each vertex, so there's 1,438 vertices on this object. Each one has a position that needs 3 floats to express it. Each one has a normal, which needs 3 floats to express it. A normal is the direction, the vector, that is perpendicular to that little polygon surface. So you might think that the normal would be only recorded per triangle or per quad, but we actually do record the normals in the gaming situation per vertex. And so this gives us the ability to define when edges should be hard, meaning that there's a big change between the vertex normal on a triangle that's on this face facing this way as opposed to this way. And then if I zoom in, let me turn on shaded wireframe. Okay. So for example, the vertex here, so this triangle here, let me zoom out. Yeah, perfect. So this triangle here has 1, 2, 3 vertices, right? This vertex has its position um, and its normal. So the normal, imagine a line shooting out here that's perpendicular to the surface. Um, and now there's 3 normals, and then those normals are kind of averaged together to get the normal on the face. And if a face next to it has the 3 normals get averaged up, and there's a normal for that whole face. If the 2 normals are very close in their angle, their direction, then there'll be a soft edge, a softening between the 2 polygonal faces. Now we have a triangle, a different situation with this triangle and this one, right? Because this one is facing almost like 90 degrees from this one. So it takes these 3 normals and averages it, and there's this normal pointing out of the face this way. And then there's 3 vertices here, and there's a normal right here. It's pointing out, and it's a very different direction than this one. It's like 90 degrees. They're very differently oriented. In that case, the normal of this face is so different in its direction from this one that this edge will be rendered hard. It'll have a hard edge. So let me go back to shaded. Notice that remember where the 2 triangles were here? You can't even see the difference between them because there's soft edge between them. They blend together to appear as part of a larger continuous surface. Now that the triangle that was here, as compared to the triangle that was there, look, there's a hard edge because there's a sharp transition. You can even see the hard edge here. All the triangles that have their edges shared between the ones down here, they're going to have a hard edge because their normals are pointing very differently. The normals also tell how much the light should hit a face. So notice that the faces here are more dimly lit. Their diffuse texture is darker than the faces that are here. These faces point more, their normals point more directly toward the light source, the big directional light source, than these normals here on this side part. So these normals are pointing more toward the light. They get more a lighter, their diffuse color goes more towards white, where this one goes more towards black. And that's because of the 3 normals that make up the face. You take the average of them for the face normal to figure out how much that face, its diffuse color, should be impacted by the light source, and also if a hard edge should be drawn to its neighbor triangle or a soft edge. So does that all make sense? In a high level, in a conceptual way. I want to rotate this object toward the preview camera. I'm having a tough time with it. Okay. So that's why when you rotate it, and there's like there's a fake light source in here that's somewhere coming from up here. That's why when I rotate it, this whole big part of the face is facing away from the light source. All of its faces are angled away. That's why they're darker. And when you move it more toward an angle of the light source, they're more illuminated. In fact, if I take the directional light source, and it's hard to rotate something when you're not looking at it, but if I start rotating this thing in such a way, there's the, I don't think it's just the directional, no, there's like another light source in here. Let's see if I can create light, point light. There's like some Okay. Doesn't seem to be. It does seem to be impacting the symbol. Yeah. Okay. So it'd be. You see how it's kind of illuminating the top of this face, but if I move the light underneath it, it's kind of darker now. And that's because it looks at the normals of the faces compared to the light source to see if it should be lit up by the light or not. All right. So if I go back, so that's what normals are. And you need 3 floats because you need X, Y, Z to define a direction or a position. And the normal is a direction, and the position is a position. Tangent, 4 floats. In this hole, I don't know what the tangents are being used for, and so I'm just gonna not talk about it. The UV sets. So notice it's UV 0. You can have multiple UV sets on a model, on a mesh. You can have like UV 1, 2, 3, 4, 5, 6, and there's some limit. But these are 2 floats, a U and a V. And that's what I wanted to do. I wanted to download a UV editor in Unity. I'll have to do that next time. But the UVs specify, basically think about a 3D mesh. You unwrap it and apply a texture to it. So I'll quickly look at like a UV and just look at the images. Yeah, so you can almost tell with a human creature how they're like almost like if you were to skin them and wrap their skin out. I know it's not the nicest way to think about it, but you have to take a 3D object and like unmap it, cut it up, and lay it out so that it's flat and it can receive texture coordinates. A cube is a little bit more straightforward. You can see how this cube you can like unwrap it. There's certain cuts you can do so that you can put all of the faces of the object laid out onto a 2D space, and as the goal is to have as minimal number of cuts as possible. But there's a balance between cuts and distortion. Like you could take a whole 3D model and almost like do no cuts. You see, there's like a distortion here. Like that, you have a nice checker pattern here, but it looks just all mush and squashed and stretched all over the place here because it's not laid out nicely. There needs to be more cuts. So there's a balance between cuts between faces and distortion, texture distortion, because you can't take a 3D object and put it in a 2D space without cuts. That's like a whole class of itself, but just so you a little brief talk about what UVs are, and that's how you lay textures onto an object. Indices. Indices are the triangles. So 1,220 triangles. It takes in this model. It takes this many vertices to define this many triangles. Now the indices of triangles is every 3 um, spots in that array, elements I should say, defines one triangle, and those numbers and those elements define which vertex, which of the 3 vertices of the whole vertex array make up that triangle. And then there's bounding box. Like if you were to draw a box around this whole thing, when it's just laying flat, what would the box be? And that's useful for like physics calculations. All right, so the mesh is an external 3D file, and that's what's plugged into this filter component. This is the file, FBX file that has the vertices and indices and triangles. This is the mesh component. Now here's the mesh renderer. So basically this is the connection point from the mesh, the vertices and triangles, connected to the material, and how should the lighting impact it. So we are using weapon disk material, and you can see it down here. So I click on that, and the weapon disk material is a shader. There's many types of shaders. The standard shader is the most commonly used, or the PBR, physically based rendering. Um, basically it seeks to recreate physical attributes, physical lighting, physical objects as best as we can do right now in computer graphics. So albedo means diffuse or the color channel. There's a texture plugged in, but you could do like a color overlaid on top of it if you chose to. But it's just like a color information, like a light source that's on top of the actual texture information. Usually, if there's a texture plugged in, it's white. Render mode opaque. There's no transparent parts. Transparency is expensive. So this is the texture map that's plugging into this channel. Is called launcher textures. So it's called weapon disk is the material that's connected here, and this material is using, here we go, launcher albedo PNG file for its diffuse colors. Now this looks strange. This is the object's base color laid out in a 2D space that gets applied onto a 3D object. And you have to take a look at the UVs to get an understanding for how that connection is made, but that's being applied onto this object. And UVs are the only way to deal with textures onto a mesh right now with our current gaming technology. So the weapon disk material is a shader, a bunch of code. In fact, if I say edit shader and let me just try compile and show code. I don't know if it'll work. Standard shader is the most complex shader. I'll show you that it's a massive piece of code behind the scenes. But if while it's generating itself or whatever it's doing, if you look here, the connection between shaders and materials are that a shader code is different than a C# code or JavaScript or C++, in that the shader code is run on the graphics card, and it's run over what's called a vertex pass and then a fragment pass. So a vertex pass means whatever the code that's written, it is actually processed over each vertex of the mesh. So think of like it loops. Think of like looping when you loop until you're done with your code. Well, in this case, it's automatically like done. You just have to know how the shader code is going to be doing this. But the vertex part of the shader code actually loops through each vertex and does whatever it is that your shader code is saying to do. And then it goes through the fragment shape. So it goes through all these vertices on this thing, does whatever it is that the code says to however to render it. Then it looks like the fragment. It'll look at, well, which parts of this mesh are going to be rendered to the pixel that's on the screen? What fragment is that? And how should we manipulate it? How should we color it? Do whatever. So there's use cases for both, but it actually moves through all the fragments. It does something too. So it's a completely different coding paradigm. It's very strange, and it takes a while to get used to. But this is what our shader looks like, the standard shader. And if you move through it, it looks crazy and weird. And yeah, there's a lot of lessons. Actually, I think eventually we'll be doing another class like the model. Some class will just be on shaders, but that'll not be yet. But just know that it's a big, massive piece of code. All right. But these properties are exposed out, much like values are properties in a C# script. Meaning these are variables that are exposed out from the shader code and are exposed through the material. All this stuff here is the properties that was being listed out. So I'll just jump back quickly and say, okay, color, texture albedo, and that is, if I jump back here, that's what this is. Texture albedo and main color thing over here. It's just nicely done in a user graphic way for you, a GUI way, graphical user interface. So you don't have to like look at that raw code bit. Now, the reason that it's called a material is that the shader does all this complex stuff, and you can change how it does it by these exposed variables. So you might want to reuse the same shader over and over again in many different ways. For example, this standard shader has got nothing is used in this project probably 10, 20, 30, 40, 50 times over, but each one is a different material. It's a copy. Each of these are copies of the standard shader. The same shader, if I click around here, notice they're all the standard shader. It's just the properties, the values of the properties changed. So why write the standard shader code over and over and over again? That's stupid. A material is like an instance of that shader, and then you can change all the properties you want on it. So material is like a customized shader. It's all the exposed public properties can be tuned to your heart, but the shader underneath is the same. So you can have multiple materials of the same shader. You don't need to keep writing out like standard shader 1, it's for weapon disk, and standard shader 2, it's for weapon disk transparent, and standard shader 3, it's for weapon launcher. Don't need to do that. That's what materials are for. So material is just like keep copies of the same shader, yes or maybe or not, but they're exposed to properties that you mess with. All right, that's a shader, that's a material, and the 2D textures that get plugged in. If you need more complex shading situations than just straight up one color applied across the whole thing. So that is shaders, materials, and textures. And if you are going to use textures, you need UVs on your object, on your 3D object, so that there's a connection. Like, how does this 2D texture get applied onto a 3D object? I don't know. The UVs tell you that. Just to wrap this up, metallic is like the shininess. Certain objects look shiny, some look rough, dull. Look around the room around you, look at woods and metals and shiny plastics and dull carpet, whatever. Normal maps give the illusion of more surface detail than actually exists on your mesh, the vertices. Occlusion is like self-shadowing, like little shadows and crevices make it look more realistic. Emission is the glow, self-illumination, and so on. That's pretty much as much you need to know. Yeah, so that's the mesh render, and that's why there's a shader sitting at the bottom that's connected here. Now is the filter and so on. So I know this is all like just crazy crash courses. It's just to give you like a grounding, a high level. Like we'll dive into little deeper areas here and there, but in general, um, is there any questions on the mesh renders? Is there any on how these materials and shaders and meshes are like kind of sitting your project as files? Now they're connected up through the hierarchy to be placed into memory to be run in your game scene. Is there any questions on that? Nope. All right. Yeah, most of you are still here. I saw like one or two of you were leaving, just making sure. Yep. Good amount. All right. So in the remaining time, I'm going to start going through the game manager script, unless like no other questions right now about the meshes or the particle systems, right? The particle systems had a lot of the same components, right? Like what type of shader is being plugged into either these like 2D billboard graphics or actual meshes that are being piped through this particle system, right? All right, let's start to just do, I'm not going to go crazy, But look at all these managers that are sitting at the top of this scene. Like, what's going on? I don't know. So I was just kind of digging at them briefly before class, and start looking at them a little bit. So notice um, over here, this game flow manager has a lot of properties exposed through the inspector, and it's nicely formatted. There's some headers in bold, there's some spaces, and what have you. So that's what all this is: headers and tool. I'll notice tooltips. So if I hover over stuff, there's the tooltip. End scene load delay has a tooltip of this. So if you go back here, end screen load delay, there's its tooltip. All right, and it's a header. So that's the header above it says parameter, and this thing has a tooltip. So these are all publicly exposed variables. Um, I'm going to keep this kind of high level. I don't know everyone's scripting background, um, but I'm just going to do like a high level run through of some of the code. And if this stuff's not making sense, that's completely fine. What's actually useful for me is like as you get hung up on stuff, you can like email me or something, like just contact me and be like, I didn't understand this or that, and then that helps me kind of guide what I should talk about in the next class. So anyway, if stuff doesn't make sense, just message me and I'll start modifying the next lecture. So in either case, all these are used, all these properties or fields are used later on. They're just variables. It's just they're exposed. It's super easy to tweak these in the inspector for playtesting so that you don't have to go back in your code and keep changing stuff and saving it in Visual Studio and going back to Unity and playtesting. Notice all this stuff is wrapped up in a nice new namespace that's just for this game. That's for organizational purposes. In this case, we have our game flow manager. As I hover over it, notice the class name is really unity.fps.game.gameflowmanager. Whatever the namespace is, dot class. And that's so there's not this clashing. If you have, notice we're importing the Unity engine, the Unity engine scene manager, and whatever else there could be a risk that within these libraries we're importing in, there's already a class called GameFlow Manager. So if you don't want to have the accidental clashing of, whoa, which class did you mean when you're calling later on, you're referencing GameFlow Manager? I don't know, because there's a GameFlow Manager in your code here, and there's a GameFlow Manager in one of these libraries you're importing. So that's why we use namespaces. And here they're putting everything under this FPS document. The class is usually named same as the file, as seen here. Usually you have everything publicly exposed in the inspectors up at the top. And so when you see this type of member M dash, so there's different type of coding conventions. People follow Google style. People follow web-based style. People follow game-based style. It's just like, and then there's like different languages like JavaScript or C# can have different conventions. This is just a convention that you might see. That just means it's an internal member variable that nobody else can use. That's why when it's not public or private, by default it's private. So this float can only be accessible by this class. That's why it's a member only. If you ever see something like this, get and set, that means it is a oh man, what's the term for it? It's not property. I guess it's property. Someone can type it out. I'm having like a brain fart. But basically, what it's saying is when you have these get and set, it means that you have to. So this is a public variable called game is ending. Now the get is the same as whatever is listed out here. So you can reference, you can read this variable for outside the class with other classes. It's public, but you cannot set it outside the class. So these type of getters or setters I think when you use this, it's called a property, and that's why the variables up here called fields. But I'm like been working in JavaScript, and they don't have this convention of fields and properties. Everything's just a property. I think when you just declare a variable in C#, it's known as a field, and when you use this get and set convention, it's what's known as a property. In any case, in this situation, you can actually put, you don't have to always just get this variable. So notice that it's uppercase. They uppercased all these up here as well. Normally, the fields are like lowercase camel case, and the properties are uppercase camel case. But whichever case, this means that only this class can change this bool. But normally, you can you might have some more checks. So sometimes when there's a set, you might want to check, like, does this make sense? There might be some parentheses and more lines of code in here. And it says, okay, you can set this variable, but let me just check to make sure that what you want to set it to is makes sense, and I'll do some safety if statements or whatever else you want to do. That's why the value of properties is you could put multiple lines of functionality with that. In any case, on Awake for this game flow manager, it's adding listeners to this event manager. You can right click on it and say go to definition, and there's this event manager class. It's static, meaning you don't have to instantiate it into an object. The class itself is basically like one object. It already exists. All the static stuff is already instantiated within the class. And it's used for when you want to create stuff called singletons, which means there's only one instance of this class. It doesn't make sense to have more than one. A lot of managers are like this. In this case, um, in this case, there's Event Manager, which has a lot of this functionality. It lets you add listeners, remove listeners, broadcast events, clear stuff out. Events are really useful when you don't want to like connect up your objects like and make like a messy connection like spaghetti code. They're all like you can't manage all these connections. You don't know what's happening. So it's much easier to have these event systems where it's like classes can register for certain types of events and listen to them, and they can remove themselves, and I can like trigger these events whenever certain things happen, and I don't need to always know who's listening, who's not listening, and it's like a lot less cognitive load to think through your code. So in this case, the game flow manager is just saying, hey, I want to add myself, one of my methods, if I move down here, this method here, as a listener onto this event. So what is this event? So if I go and look at that code, there's this event class. Looks like it's static as well. And it has a bunch of events in it. Stuff like objectives are updated, all objectives are completed, the game is over, the player dies, the enemy's been killed, a pickup, something was picked up, some type of ammo was picked up, some type of damage happened, and some type of display needs to happen. So these events are defined, and you can listen to them. Meaning other classes can listen at and remove themselves as listeners whenever they need to, and then other classes can come in here and determine when things have happened and actually call these events. So if I'm the player and I run up to a pickup, either the pickup or the player will say, hey, a pickup event happened, and I don't need to like think about all at once. What does it mean when a pickup happened? Okay, I need to update the UI. The player, the health, what type of pickup was it? I got to update the player health. I got to change the objectives. You don't need to worry about all this. You can just have your piece of code, maybe even the pickup itself, just initiates, oh, a player collider touched me. I'm going to initialize this pickup event, and I'm going to go destroy myself. And I don't have to care about anything else. And then, because the player was listening to the pickup event, the pickup kind of brought, like, said, okay, I want to trigger the pickup event with my name. And the name of the pickup was armor pickup, right? And so the armor pickup collider received through the physics system that the player collider touched it. And there's a little method on the pickup that says, okay, when a collision event happens, if the other object that's colliding with me is called player, then I'm going to go call the pickup event in this static event class, because everyone has access to it. And I'm going to go pass in a string of my name called armor pickup, right? And then so this pickup event gets broadcast out. Whoever's listening to it, in this case, maybe the UI, maybe the player, is saying, oh, armor pickup happened. And so the player's internal stats plus 30 on armor. Maybe the graphics change. Maybe the armor mesh on the player is told to improve or update. Maybe the UI like meter changes. Like, oh, I got to move up a third. Whatever the parameters are on the meter, move up and be like, I now have 30 extra armor. So that's a real benefit of events. As you start coding more and more, a lot of this becomes a lot easier. This is very conceptual level, and if it's confusing, it's okay. So the game flow manager listens to when objectives are completed and when the player dies. It doesn't worry about when it's actually triggering. It's just listening for when somebody triggers it. Another piece of code triggers it. So what does this stuff do? When all objectives are completed, so this is the lambda expression. It's a way to like declare or call method other pieces of or you call them functions or methods. Again, you never used it. Don't worry about it. This is just saying whenever this method gets called, go call this method. Endgame true. And on player death, call endgame false. So here's the method endgame that's expecting a bool. So this is all super high level, this game flow manager. It's just listening if the game was won or if the game was lost. Whatever conditions happen. And then it does stuff. Okay, let's lock the cursor. Unlocks the cursor. Okay, so I guess the mouse cursor gets hidden because you're moving the character around. You don't want this mouse cursor. Let's make the mouse cursor visible again, because the user has to go use the UI to say, do I want to play the game again or do I want to end the game? So some UI changes happen. The end game canvas gets turned on. The screen to load up. If the win screen or the replay screen if you die, and then how much time before we kind of like fade out and what have you. So a lot of this, and then different. And so instead of like maybe playing the ambient wind noise, maybe we're switching out and playing some other type of audio, and we're displaying different messages and what have you. And so whenever this object gets destroyed, we're removing the listeners. It's just good convention. If you don't exist anymore, the event system shouldn't be calling on you because that might cause errors. So if you get destroyed, just remove your listeners. And that's it. That's all that's happening at this high level. Yeah, there's some audio. So on start, set the master volume up, basically. And on update, if game is ending, ramp down the audio. And that's it at this massive high level, right? It's pretty abstracted script. I think I'm gonna wrap up class. Yeah. So all these managers are like super high level on how to manage the events, the big event things. Not worried about any of the details. So you got to focus on very modular and abstracted parts when you code. So I'm going to wrap up this video, and we'll continue on